A circular clock can be divided into 12 congruent sections. Find the measure of each arc in this circle. When we're looking at a standard clock, it's already divided into 12 congruent sections. The measure of a circle is 360 degrees. We have 12 congruent sections. Therefore, all we have to do is set this equal to 12x. To solve for x, which would be the measure of each angle, we'll divide both sides by 12. That will leave us with 30 degrees. Part B, find the measure of the minor arc formed by the hour and minute hands. When it's 7 o'clock, we know we have 5 sections. Therefore, all we have to do is go 5 times the measure of each section, which is 30, which is equal to 150 degrees. Part C, find a time at which the hour and minute hands form an arc that is congruent to the arc in Part B. This one has many answers. One answer could be 5 o'clock. When you take a look at 5 o'clock, you will notice that we still have the 5 sections. 1, 2, 3, 4, 5. 5 times 30 is 150. Another answer could be 8 o'clock. We still have the 5 sections. 9, 10, 11, 12, 5. 5 sections. 1, 2, 3, 4, 5. Another answer could be 6:05. Another answer could be 7:10. Alright, the next problem will require us to use the equidistant chords theorem. It states that in the same circle or in congruent circles, two chords are congruent if and only if they are equal distance from the center. Remember, when we are talking about a distance from a point to a line segment, we're talking about the perpendicular segment from that point to that particular chord in this case. Therefore, when we take a look at the problem, we know that the distance from point P to chord FD is PJ, and the distance from point P to chord AC is PG, and that means the lengths have to be equal. We can substitute our values, solve by subtracting x from both sides, then by adding 1 to both sides, dividing both sides by 2, we have x is equal to 3. Now we can use x is equal to 3 to substitute in for the length of PJ. We'll substitute it in for x, multiply, and we have the length of segment PJ is equal to 8. It was also given that the length of segment FD is 30, and we know that the length of FJ is half the length of FD, which is half of 30, which is the length of segment FJ is 15. Since we know two sides of a right triangle, we could find that third side by using the Pythagorean theorem. And let's substitute our values in. Square, add, take the square root of both sides, and we're left with the length of segment FP is 17. Notice that FP is the radius of circle P, as well as EP or BP. Therefore, the radius of circle P is 17.